Efficient raycasting. 3 rules to save milliseconds on CPU. Hello and welcome to episode number 25 of the Unity Performance Task Force podcast. I'm your host Ruben from TheGameDev.Guru, and as usual I'll kick things off with a question for you. Have you ever profiled your game and realized raycasting is eating 3 milliseconds per frame? Sounds familiar? If so, this episode is for you. Raycasting is all about finding intersections between rays and your world geometry. It's a feature commonly used in every type of Unity project entertainment, VR experiences, games. You see it everywhere. That's why it's very important you learn how to do raycasting the optimal way. So, should you use raycasting in your project? The answer is it depends. But you should know raycasting even if you don't use it. First, let's discover what raycasting is. Raycasting is all about shooting a ray or line in the 3D world to check which objects are in the way. Think of a ray as a line with an origin, a direction, and a specific distance. It's a segment. The idea is to find which objects are in the way of this line. Once you know, you get information about the distance at which the collision happened, the normal of the surface you hit, and access to the game dev tweet you hit. Why is this useful? For example, if you have terrain, you might want to position the player correctly on the floor. Shoot a ray downwards from the player's position to find where it collides. Once you know the distance, adjust the player's Y position to match the floor. Another example, AI. If you're programming a soldier's behavior, you need to detect whether the soldier can see the player. Shoot raycasts to check if the line of vision is clear. If a wall is between the soldier and the player, the raycast hits the wall, not the player. In your AI script, don't try to shoot, try a different path or take cover. Another example, vehicle physics. Instead of using Unity's built-in components, shoot raycasts downwards from the wheel positions. This tells you where to position each wheel and lets you fake springs. It's much cheaper and gives you more control. Another example, crosshair colors in games like Counter-Strike. The crosshair changes color depending on the target. Aiming at a teammate, green. Aiming at an enemy, red. How? Shoot a raycast to check where the bullet would land, then check the tag of the object you're colliding with. Now, when we talk about raycasting, we're actually talking about many operations. Let's break them down. First, checks. Checks answer, is this shape overlapping with any geometry? For example, chopbox, check capsule, check sphere. You get a boolean yes, you're touching something, or no, you're safe. Second, overlaps. Overlaps find all geometry or colliders touching or inside a specific shape. For example, overlap sphere. If you throw a grenade, you might do an overlap check to see what's around the grenade and what you should damage. Third, casts. Casts detect the first collision when you move a shape from point A to point B. You can also get more than one collision, but usually casts are about the first collision. In Unreal Engine, these are called sweeps. Raycasts move a ray infinitely thin from point A to point B. Boxcast moves a box, spherecast moves a sphere, capsulecast moves a capsule. For example, capsulecast is great for checking if a character could theoretically move from A to B without touching anything. So, is raycasting expensive? Yes. That's why we have this lesson. A few raycasts might be fine, but if you're targeting mobile and doing more than a few, you need to know the cost. Chances are, if you need one raycast, you'll eventually need more. In one project I'm working on, I'm doing about 10 spherecasts and 40 raycasts per frame just to calculate the player's path. So, how do we optimize raycasts? Let's think about 3 rules. Rule 1. Restrict collision layer masks. Raycasts work according to the 3D physics world. You have collision layer masks, which dictate what your raycast can hit and what it ignores. If you restrict the layer mask, you ask the physics engine to calculate fewer possibilities, which makes your life easier. For example, if you're raycasting to position the player on the floor, restrict the layer mask to terrain only. Don't check against enemies, UI, water, just terrain. Collision layers are the layers you see in each game dev tweet. You can assign layers like player, enemy, terrain, water. When you call a raycast function, pass a layer mask parameter. Make it restrictive. Rule 2. Use non-allocating versions. If you're using allocating versions of raycast commands where you're asking for multiple hits, Unity has to create an array or list for you. Instead, use the non-alloc version. Pre-allocate an array and reuse it forever without Unity recreating it every time. For example, raycast all returns an array of hits. Unity allocates it. Instead, use raycast non-alloc. You pass a pre-allocated array and Unity fills it. Same for boxcast non-alloc, overlap sphere non-alloc, and others. The raycast query ends when there are no more hits or the result buffer is full. Pay attention to the documentation. But the key point, batching still works. Don't worry about draw calls too much, measure the end result. Rule 3. Do raycasts asynchronously. This is one I see no one using, but Unity gives you the option. Asynchronous raycasts don't block the main thread, they happen in a worker thread. This way, they don't degrade your game performance. For example, instead of physics.capsulecast, use capsulecast command. You prepare a command that queries for collisions when you move a capsule from A to B. Then you schedule that command to happen in a worker thread. At some point, the worker thread finishes and you fetch the results. Here's the trick. Schedule as early as possible in the frame and complete as late as possible. Give it time. If you schedule 1000 commands and immediately call complete, there's very little difference from synchronous raycasts. But if you schedule in one frame and complete a few frames later when you really need the results, you'll see huge performance gains. Let me show you an example from the Unity API. You create two arrays, one for results output and one for commands requests. Commands are just orders. I want to cast a capsule from A to B. You put commands in an array because it pays off to submit them together in multi-threading less overhead. Define your capsule with the lower point, upper point, and radius. Specify direction x-axis, downwards, whatever. Create the command, schedule it, and eventually call complete. The key, do this as late as possible. Give worker threads time to process. You can also schedule in one frame and complete in the next frame or 10 frames later. Just give it as much time as possible. The same applies to raycast command, boxcast command, sphere-cast command, depending on the shape you want to use. Now, you might not always be able to do raycasts asynchronously. Some raycasts must happen in real time. But for cases where you can do them asynchronously, consider it. Almost every hardware has more than 2 threads nowadays. If you do raycasts asynchronously, you're going to win a lot of performance. So, let's recap. Raycasts help you find objects or colliders in the world. We do this by casting, checking, or overlapping different shapes at different locations. Checks are the cheapest. Overlaps are a bit more expensive. Volumetric casts like capsule cast can be very expensive. These are the moments when it's important to make them asynchronous. Every time you see capsule cast, box cast, or sphere cast, try to make them asynchronous. It'll give you huge performance gains, especially if you're doing more than a few. As always, measure the cost of your raycasting. Use the profiler. Call begin sample and end sample to mark sections. Get into the habit of measuring the cost of your gameplay features. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.